is Captain Henry Kroll. And Henry's been on the show before. We all love Henry. And Captain Henry Kroll is an adventurer, aviator, miner, commercial fisherman, inventor, entrepreneur, and outstanding writer. Henry has authored several books available on Amazon.com, one of which is Cosmological Ice Ages. If you haven't read that book, it's a really good book. And you can access his websites at www.guarddog.books.com and www.alaskapublishing.com. And please welcome Captain Henry Kroll to the show this evening. Well, good evening, Captain.
Yeah, good evening, Solaris. Good evening, ladies and gentlemen, and other life forms. We're sitting here about 9 miles south of Soldotna, Alaska. We call it Slowdotna because the people that moved here from oil workers from Arkansas and Texas. So anyway, yeah, what should we talk about this evening? My hydrogen generator?
Yeah, let's start with that. Let's dive in there.
Well, the fuel prices, gas prices went up to around $4 a gallon, diesel price a few years ago. So I ordered this Brown's gas generator off the internet, and I was going to install it in my pickup truck under the hood there, and it's a big, 250 Ford truck, so I figured it would fit under there, but there's just absolutely no room. So it sat around on my porch for another 3 years or 4 years. Finally, I got ambitious and built a little box 2 feet long and about a foot wide, and I put it all in there and fixed it so you could hook it up with jumper cables to any battery or the car or anywhere. You could even carry it in the back of your truck and then run a small hose up the carburetor if you'd like, just to kind of save fuel. It increases fuel mileage at least 20%. So anyway, I put it all together, and then I happened to pick up Nexus magazine. I got this wonderful little article in there. It talked about the health benefits of Brown's gas, which is very synchronistic since I just put the thing together a few minutes before. And I looked at this article, and inhaling oxygen and hydrogen, which is what water is if you break it up with electricity, hydrogen and oxygen, it has great health benefits for arthritis and getting extra oxygen in the body helps fight off cancer and other immune diseases. And I emailed the list of things to Solaris there so we'd be familiar with it. But also you can I brought it one of those little things you stick in your nose that people carry around, those oxygen C-packs, they have this $1.20 piece of plastic, you can put it in your nose, and you can inhale that 20 minutes. According to the article, it'll take a year for every month that you inhale this gas for 20 minutes a day or 30 minutes a day. It takes a year off from your life. It adds a year to your lifespan, let's put it that way. And because of the extra oxygen and also other health benefits. And we don't know exactly what hydrogen does, but your body probably needs hydrogen also,
I believe that, yeah.
Cell. So anyway, so you can also, went down to Petco and got a little bubbler for aquariums, and I connect that up to the hose, and you can drop it in a gallon of water, and it'll hydrolyze the water. It actually adds oxygen and maybe increases the bond angle of the molecules of water to make it more wetter so that it's more easily absorbed by your cells in your body. Anyway, I'm kind of been studying this sort of thing for years, and I'm over 74 now, and so I'm, health conscious and like to be able to remain strong and healthy.
Anyway, you sound fantastic. Henry, you always sound good. Go ahead.
Well, I just urge anybody that if they want to experiment, you can also use it to increase the mileage in your car. So anyway, you can weld with the gas too, by the way. You can use it as a welder, and there are commercially available units that you can buy for welding. So anyway.
Well, it sounds like the oxygen is a cellular regenerator. And so far as cellular regeneration goes, I think it really does do that. So.
Yeah, speaking of oxygen, that may be one of the reasons why the health crisis that we have all over the world is that oxygen levels in the atmosphere are decreasing because we are burning it up. And every time we set something on fire or burn our fossil fuels, and we're recombining it with the carbon and making carbon dioxide. So, maybe we should think about getting more solar, which I'm use, of course, for my house here. I'm all on solar. And or other sources of energy, wind power too, And there's no excuse for making the oil companies any richer than they already are. I believe that oil is a good thing. We should make plastic out of it in houses and furniture and other things. It's wonderful material, but we don't really need to burn it.
Mm-hmm.
From what I understand, there's a island in the Pacific Ocean now made of plastic that's the size of Texas. It's about time we sent somebody out there to start mining this plastic that's floating around out in the middle of the Pacific between Hawaii and California. So anyway, it's all made of oil, and it doesn't decompose very quickly. It might take decades, and it's a hazard to wildlife, of course. Things eat it. But anyway, we're oil economy up here in Alaska, and I've been fighting like tooth and nail here to get more land into private hands. The kids graduate high school and they wander around in the streets and they don't have anything to do, so they go over to the friend's house and smoke pot and vapes or whatever, and then wind up racking up a criminal record and living in the prisons. And that's not the good thing. Our children are our future, so we need to have them. I think of we're on the wrong evolutionary path, is what I've been telling the local government. And we need to have them maybe take care of animals, or chickens, ducks, geese, sheep, goats, whatever, and take care of horses and cattle possibly, and that would give them something to do. But the way the system is set up, they just keep hiring more police and more prosecutors and building more jails, and they think that's going to cure the problem. But all it does is hire people with degrees in criminology and other, degrees. It's not really going to solve the problem. It's just going to make it worse. And it's a real problem here. The opioid thing up in Alaska is worse than any other state, so they say. The problem with drugs. So we just need to have land ownership. You can't have a free society without land ownership, is what I've been telling them. The communist system does not work. No communist state has lasted longer than 60 years before it falls on its face. And next year will be 60 years for Alaska before it runs out of resources, and also, other bureaucracy gets so thick you can't do anything. You can't start a business. You got 5 licenses you got to apply for. It just doesn't work.
Yeah, it's getting ridiculous.
They want to hire more bureaucrats, to watch you all the time, and you get so many of them, you can't do anything. So anyway, that's what I'm working on, trying to get more land. Now, we've got 750,000 acres over here north of Kenai in the Great Cliff area. The borough does. The borough owns that. It's just sitting on it. And believe it or not, their tax roll has a deficient tax roll of $2.5 million. Whereas if they get more land in the private hands, they could take in more taxes, and if they had jobs, these people could pay their taxes. But right now, they're behind $2.5 million. And then the state of Alaska itself, out here in the peninsula around Kenai and Soldotna, it has 3 million acres of land that's just sitting on it. It's a lot of lakes and ponds. It could be used to raise fish and other protein, and also, if they divided, say, 2 million acres of that, you would have 400,000 5-acre parcels if you went with 5 acres. And that's tremendous a lot of land. People would come up and just to make stipulation that they produce crops or something on that 5 acres, maybe 10 acres for a family or husband and wife, something like that. And I've been reading up on farming over in China. They've proved that acreage between 5 and 17 acres is more productive than working it with machinery. Working small plots of land by hand is more efficient, and per acre you get more crop per acre. But there's a lot of things we could do here. They have greenhouses that one side of them is insulated. And the last month's National Geographic had a picture of an aerial photograph of greenhouses in China that just seem to go on forever, out to the horizon. And then there's a subdivision of townhouses, multi-story townhouses over to the left, where the workers live there, and they look really nice. They're really nice-looking buildings. But it takes a lot of manpower to run those, to plant the greenhouses and take care of them and water them. But they're all set up with covers, that insulated blanket that rolls down automatically at night to insulate the greenhouse to keep the temperature up inside. And the back wall is really heavily insulated so that it absorbs sunlight and heat. And they're not round, they're more like obloid shapes. They're kind of flat behind where the sun hits, and then the front part is curved so that the insulating cover can roll down there. They have them set up automatically so that when the sun goes down, they cover themselves.
Mm-hmm.
And
that's nice.
Anyway, yeah, we could do something similar to that in some areas here. And we're actually in zone 6, agricultural zone. The temperature has improved here quite a bit. We don't really have a lot of sun for a couple months, but the temperature has come up about, 10 degrees in the last 30 years or something like that.
Wow.
We've had winters that went as cold as 40 below. I saw one winter about 20 years ago went to 40 below for a couple days, and 39 below. Mm-hmm. And this last winter, the coldest we had was about 19 below or something like that. It was 10 below for a while. It wasn't bad at all. And there's no snow here to speak of.
Really?
Very little snow. Mm-hmm. Yeah, we only have maybe about a foot of snow, a little over. So anyway, I've written several books, and one of them I spent 7 years writing it. And I wrote it I didn't intend to write it. It just that a friend of mine, and I called him up, and we were looking at ice cores, and where they drill down through Antarctica, and they have graphs of the contents of the ice and CO2 and all of that sort of thing. And incidentally, the oxygen content of the Earth was a lot higher than it used to be. Say a few million years ago, we're up to 30% oxygen. Recently, they've analyzed bubbles of air trapped in amber, and it's about 30% oxygen. But the mainstream says right now that our oxygen is 21% or 20.5% of our atmosphere. But, I think it's a lot less. Mm-hmm. And I know it's a lot less in government buildings where our bureaucrats are making important decisions about our welfare. Because of those old air filter systems and the virus floating around in there. And those are the people that are telling you what to do, So I don't know how that can work out too well.
No kidding. That's so true.
Anyway,
I agree with you on that.
Just think about it, just ridiculous. But anyway, about the time of Moses, we thought that maybe it was around 30% oxygen. So, a burning bush erupting in the mountains would be a reality back them days. Could very well happen, but whether or not God would speak to you to that bush, that's another story. But so anyway, we're writing this. I started talking to Brad. Brad Guth died on me 2 years ago, my co-author, and I kind of miss him. I inherited a radio from him that I play every day. That's about it. His wife lives down in Olalla, Washington, but the guy was the smartest man that I've ever met. I couldn't speak to him for 10 years or so, and finally I got to where I could wedge a sentence in there, and he would try to understand what I was talking about, and I have to think a week or so about what he said before I could figure out what he's talking about. He's one of those guys, but he was Mennonite descendants, and he worked on complicated machinery, and he built circuit boards for various ships and yachts around Seattle area. He even worked on the Alaska State Ferries, the Tustamina, and that's another story. But he didn't want the job actually, but all the shipyards kept referring the job to him because they didn't want to deal with fixing the stabilizers on the Tustamina. It's a pretty good sized ship. It's about 300 feet long, I guess. They lengthened it. And it's old now. It went in service back in the late 60s. And it goes between Dutch Harbor, and it gets rough out the Aleutian chain, but the stabilizers never worked on it. And they have three-phase motors on fins that turn up and down as the boat moves through the water to kind of level it out as it travels. And I remember I rode on the second trip over to Kodiak on the thing, and turn it on, and it just about roll a ship over. It was backwards, or something was wrong with it. But so they gave Brad the job about 5 years ago, and they hauled the Tuscaloosa up in Seward in dry dock there. And well, he downloaded the schematic, and he built a circuit board that he thought he could just fly to Alaska, catch a ride to Seward, pull the old circuit board out, stuff in the new one, and it would work. Well, that didn't work out too well for him. But so anyway, he flew up to Anchorage and contacted my son, Henry, and he was driving a Z car that went 100 miles an hour, and he drove down to Seward through a blizzard in a snowstorm and got down there and pulled the circuit board out and put it in, and it didn't work. Well, he had to spend another couple of days there and tracing the wires down. The only thing wrong with the stabilizers to begin with was the shipyard had wired the three-phase motors backwards, so they were turning the wrong direction on the fins. I could have fixed that myself if I had a chance, but, you know, that's pretty funny, really. So, anyway, they didn't pay him right away. They had to wait another. He paid him $9,000. He bid $18,000 on the job, and finally they wanted him to do something else. And he says, "Fine, you pay me, do something for you, but you owe me another $9,000." He said. So, anyway, Brad, we were looking at ice cores, and it's an indication of what the Earth was like dating back to 400,000 years ago. And we noticed a drop in carbon dioxide at regular intervals. And I asked him about it on the phone, and he'd already started looking around for something that would help mop up carbon dioxide in the atmosphere. And there's only one thing that can do that, and that is an increase of light to Earth to make the plankton grow in the oceans to mop up the carbon. And the oceans cover most of the world, close to 4/5 of the world. So that's a big old heat sink there that mops up carbon, and a lot of it's absorbed into the water column also. And the sun doesn't change its spectrum and suddenly start putting out more light to mop up carbon dioxide. And if you look at the layers of coal and the oil and the limestone here on Earth, there's just no way the sun could have made all that stuff. I looked in my encyclopedia, and there's layers of limestone up to 12,500 feet thick in some places. The white cliffs of Dover stick up out of the ocean, several hundred feet. And that's all made by plants in the ocean, and it takes photosynthesis and light, photons coming in from somewhere to make all that. And the sun, back in the ancient times, Carboniferous era, or prior to that in the Cambrian era, when life first got started on the planet, it didn't have very much sun putting out as much as it does today. It's slowly increasing its output over the many thousands of years of sun. It might take 1 billion years before it engulfs the planets or something like that, but it's very slowly increasing its output. And there's no way the sun could have made the oil that makes your car go down the road or heats your house, or the coal, 100 feet thick layers of coal of anthracite. You can't even wrap your mind around that stuff. To make 1 foot of anthracite requires 40 feet of trees and grass compressed down to 1 foot thick. I learned that from a geologist in Sterling after I started writing the book. We couldn't find it in any text anywhere. And lignite, the softer coal, is about a 20-to-1 compression ratio. So if you got 100 foot of coal like you do in Pennsylvania, Utah, Colorado, other places, 100 foot thick deposits of anthracite, you had to have 4,000 feet of trees and grass compressed down by a 5-mile high sheet of ice at one time or another. In order to make that much plant growth, you had to have a tremendous high-pressure atmosphere with lots of carbon dioxide for the plants to eat or to grow. And you had to have light coming in, massive amounts of light. And plants can utilize ultraviolet light. It's beyond the range of human sight. And so Brad had already started, when I called him up a couple times later, he'd already started looking around our sun for another source of light and heat. And it just so happens that we're heading towards Sirius A and B at 7.5 kilometers per second, and it's 8 light years to the south of us. It's the brightest star in the sky. And he had already started working on the mathematics of the orbit period around the Sirius star system. We're heading toward it at 7.5 kilometers per second, at 8 light years away, and it's 3.5 solar masses, counting the white dwarf that orbits around it. The white dwarf is 1.5 times as massive as our sun, but it's only the size of Earth.
Mm-hmm.
And it puts out 100 times the light of our sun in the UV spectrum. You can't quite see the light. So when you're looking at the brightest star in the sky, it flickers and it plays tricks with your eye. It's down low on the horizon below the 3 stars in Orion's belt. So anyway, I couldn't wrap my mind around that for a while, and finally I decided to figure out where we're going in space. I like to fly planes and navigate boats and stuff all my life. I've done that forever. So I thought about it for a week or so and finally found a constellation map of sorts. And we're in the center. If you lay down on the ground and look up, you see these stars in these little charts in Astronomy magazine. They show all the stars in the sky at various months of the year or whatever. And you just get a constellation map. And, well, I read in my encyclopedia we're heading toward Hercules, which is kind of to the northwest of us, the sun, on one of those star maps. So I drew a line from Hercules to the center where we are. We're in the center of these maps. And I extended out to find out where we came from. Mm-hmm. And we live in this giant galaxy. It's about like a big fried egg, and there's billions and billions of stars, but they're only about 300 light years thick. We're kind of a thin rim in this area here. And I extended the line out, and it winds up in Orion, and Orion's a birthplace of stars. Mm-hmm. You can see new ones coming out of there. And it happens to be the nearest birthplace of stars to us. There are others that are many thousands of light years away, and we're leaving that area of Orion. So we had to have been born in Orion, mm-hmm. which is really enlightening because that makes me the only person on the planet that knows where the sun was born, which is weird.
Interesting. And also the sacred sites, they correlate to Orion across the globe. That's very interesting as well.
Exactly. Well, I made it into 2 books. The second half is more esoteric, and it talks about all the ancient monuments and various things around it, pointing at Orion and Sirius, the dog star. Anubis was kind of like a dog in an Egyptian, and he was their pilot, supposedly. He was their navigator. Mm-hmm. And so, I don't know, they probably had star travel at one time or another. So if we're leaving Orion and heading towards Sirius, which is between us and Orion, the whole group of stars that we're in, there's about 100, they call them moving groups. And they're gravitationally ruled by the 2 biggest stars in the group. And that's not our sun. The 2 biggest stars are Orion and Procyon. I don't mean Orion, I mean Sirius and Procyon. And both of those stars are weird. They're not from here. Mm-hmm. Our galaxy is eating up 10 major size galaxies, according to Astronomer magazine in 2003, Astronomy magazine, and 100,000 smaller star clusters. And some of those star clusters could have been 10,000 stars. Mm-hmm. But it gobbles up matter in space, just like Pac-Man, the old Pac-Man game. So they're weird. I've got Timothy Ferris's book on galaxies, and there's hundreds of illustrations in there, what happens when they collide, and different mathematical things. It's really a coffee table sized book, pictures of galaxies and drawings. But anyway, ours is Pinwheel Galaxy, and it's even bigger than Andromeda, they say now. Ours is huge. And we're in the Orion Spur, which is about 30,000 light years, 28,000 light years from the center. And it rotates, and it doesn't have enough gravity, apparently, to keep us all in line. So these arms of the stars, these spiral arms, are receding from the center as it grows, and it makes more stars, and it kicks them out as the thing rotates, and it makes one revolution every 250 million years, they say. And anyway, we're 1,200 light years from our birthplace. So what happened, you got to run it back in time from the beginning. We were born in Orion. The planets were formed. Some of them probably weren't from this solar system. They could have been swapped in. We don't know. Anyway, there's a lot of dust and dirt that were formed in the asteroid belt between Mars and Jupiter. Anyway, it's still a bunch of asteroids out there we haven't even cataloged yet in our own solar system. But anyway, we left there about 2 billion years ago, and Earth froze up for 1 billion years. It's called the Huronian glaciation. The whole Earth was covered with ice at that time. It had one ocean and one continent, and it was about half the size it is today. So there's no way, there was no life on the planet. So there possibly could have been some spores or some life down under the oceans, because life seems to proliferate everywhere in the galaxy, just everywhere in the universe. And also during that billion years ice age, we could have collected lots of spores and dust and eggs and who knows what from space, as various asteroids that came in, and depending on where we were in space. But anyway, somewhere along the line, we drifted out of there at around 18 or so or less kilometers per second. We're traveling 19.5 kilometers per second toward Hercules right now. But you see, this group of stars that we're in is about 28 kilometers per second, or 27 toward Hercules, because we're heading back in the opposite direction toward Sirius. It's kind of hard to envision all this. Just about have to lay it out on a coffee table or some with glass. I use coffee cups and other pieces of smaller objects for the white dwarfs, you see. But anyway, it's all this movement. You have to understand that we're traveling many directions at the same time. Even as we travel around the sun at 66,000 miles an hour. I mean, everything's in motion constantly. And Earth traveling at around close to 1,000 miles an hour at the equator as it rotates for 24 hours. So anyway, we got near these other stars that were swapped in, Procyon and Sirius. And Brad was talking about a mutual gravity alignment point. And I had to think about that a while. You get between these two stars, the gravity's equal in all directions, and we're moving. And then as this little white dwarf comes around, it's more mass and more gravity than our solar system. It orbits Sirius A every 50 years. It came around and grabbed hold of us and probably put us into a tight orbit around Sirius. And it was the extra light. Sirius A puts out 4 times the light of our sun. It's 2 solar masses. And Sirius B puts out 100 times the UV light of our sun. And it's 1.5 solar masses, but it's about the size of Earth. 1 teaspoon of it weighs more than a city bus. It's made out of particles of atoms and not actual elements. And Sirius A has a titanium atmosphere, and Sirius A orbits around it in a slightly elliptical orbit at 8 to 12 AU. 1 AU being an Earth distance, an astronomical unit is 93 million miles. So at 8 AU, it could very well feed off of Sirius A. In other words, if it was doing that, it may put out more than 1,000 times the light of our sun. We have no idea. There's no way to measure that. But we can compute the light now that would strike Earth as we get, say, within 1/10 of a light year of the Sirius system. We would get closer to it. So anyway, what we did is we calculated the orbit period around the Sirius star system. And I've taken it to 2 different astronomers, and I laid the math out for them. And they start nodding their heads after a while. They have to agree with me. There's no way they can, because the math doesn't lie, You just So it's 1.5 solar masses. The whole thing is, so it's got more gravity than the Sirius B does. So the mass of Sirius A and B is 3.5 solar masses. And then you got the galaxy behind there, which is transmitted from star to star in a big Fibonacci sequence, kind of like a sunflower. And so you got to multiply the mass difference times 4 to actually calculate the gravity in that general direction. Which means that if you took a conventional rocket and wanted to go over to the Sirius star system, you'd only have to go about 12% of the distance, and you shut the motor off, and the gravity would suck you in over that direction, but as opposed to the gravity of our sun. So, but anyway, we're heading that way now. So we calculated the orbit period. It matches the Ice Age cycle, 105,000 years. So that could be the real cause of Ice Age, and we're convinced of it. And not different changes in the climate, not anything else that they talk about here on Earth. It's just additional light and heat melts the ice caps as we get close to Sirius, and we're in this highly elliptical orbit right now. We whip around it, and then we go back out. And the next time we may not even return. We get out that it's 105,000 year orbit period, so it takes a long time to get back around it. And then we lose the ice caps, and then we go out to 9 light years next time around. We're at 8.5 light years right now. We were at 9 light years a few hundred years ago. And that's how it is, So, how far would you have to travel through space to find an identical scenario where our planet would be orbiting around a white dwarf, another star system that would build coal, oil, and limestone to make the energy on this planet? It's just mind-boggling. You cannot imagine the chances. How far would you have to travel? How many millions of light years? But yeah, it's so.
It's fascinating
anyway,
data.
This coal.
Go ahead.
Yeah, you just can't wrap your mind around how all this stuff was made. It's just impossible to make this. I mined that coal down in Homer when I lived there for 13 years, and I really could see it was made out of trees and grass. You could see the leaf prints in some of it, fossilized. Some of it's actually fossilized wood, but has gas in it too, quite a bit of methane in it too. And it's lignite coal. We heated our home with it in Halibut Cove, and I'd mine it for my neighbors also. I'd go pick it up and had a barge and a boat, and I'd load that up. And never really understood how it was made, but I knew what it was made out of. And then I started putting 2 and 2 together, and how the light would come in and make all those layers of coal. And limestone is the same way. It's my Encyclopedia Britannica says that the continental United States is limestone from the Carolinas all the way to the Rocky Mountains. And it has an average thickness of 3,500 feet. And that was all made by light. And it took carbon out of the air and out of the water and laid it down as calcium carbonate using plants in the oceans called coccolithophores and fortifera and other plants and different types of shell like limestone, glabogina, they call it. So...
And also, this is in your book.
Okay,
I just want to ask you real quick here.
Yeah.
This is in your book, Cosmological Ice Age, right? All of this data.
Right. It's all in there, how those energy was made on this planet. And if we don't know how the energy is made, should we even be burning it? Those are questions that I have to ask,
Right.
So I tried to figure out where it came from and how much energy went into it to make all that coal, oil, and limestone. And it wasn't sun. The sun didn't make that stuff. But, maybe we're worshiping the sun god, wrong sun god for the last 3,000 years or whatever. But, it's understandable that people would worship the sun having just come out of an ice age. And we were covered with ice not that long ago. And there's a lot more to the book also than what I've been telling you here. It's all laid out there, but...
That's incredible data. I love it. And we do have a quick question for a second here, Captain. We just have a question here in chat I wanted to cover before I forget. Let's see. Is it possible that when our solar system left Orion, that the plasma density of the Orion-Birkeland current was technologically subverted in order to create a matrix plasma bubbler around us in order to imprison us in a holographic matrix?
I kind of doubt it. This space is cold and Earth froze up for 1 billion years. But we had a high-pressure atmosphere, and it was probably 500 miles deep atmosphere because it had to be 750 pounds per square inch and maybe 20-30% carbon dioxide. And as the Earth expanded, it reduced the air pressure down to around 200 to 300 pounds per square inch during the Carboniferous era, when all this coal and oil and limestone were made. We had trees over 1,000 feet high, maybe even a mile high. They found some fossils, that fossilized stumps that could be, like 20 miles in diameter. They don't even know. It can't even fathom this stuff. You see, it's just, you'd have to be there to see it in order to understand it. It's kind of like the movie with the guys that, what's the name of that movie? Where they had these giant guys in there mining on a different planet. Anyway, it was like that. They had these huge trees. They're just mile-high trees. And there could have been some of those fossilized stumps in Utah and Colorado and stuff that's sticking out of the ground. They found some in Texas, too. They dug down. They figure they had to be 900 feet tall or better redwoods at one time. And, well, anyway, the last ice age covered up a lot of the forests and everything because it extended down as far as northern Florida and Georgia and Kansas. And then the redwoods were spared over in California. Of course, they survived the ice age just fine. The ice rotational pole of the Earth was more at the southern tip of Greenland during the last ice age, and it was suddenly shifted. I'm still working on a book called Return of the Giants that has to do with mining gold in South America. And I have a whole collection of ancient maps now that I found online, which shows Antarctica is connected to South America, and it suddenly got ripped apart. And then they had these westerly seas where they couldn't sail over there anymore. But the Earth was tilted, and the ice cap on the southern hemisphere laid over Hobart Island, and New Zealand, the southern fjords of New Zealand were cut out with ice. And so this huge ice cap was in a different location. So the Earth rotation, or the Earth was tilted around 23.5 degrees in relation to the sun's rays. And it may have been terraformed. We just don't know. We have no clue. Maybe the guys that came here to mine gold, the Anunnaki or whatever, they could have brought the moon in, bounced it off the Earth or something to make it tilt 23.5 degrees so that they could thaw the ice caps back. Right. Because you can't mine gold when you got mile-high sheet of ice over everything. And in South Africa, they ran out of gold there. And so they moved up into the Middle East during the Ice Age. And after the flood, it dumped 20 feet of gravel over a lot of the mines in South Africa. There's a city down there. They've been uncovering it for years. A couple of archaeologists are working on it. It's twice the size of London or Los Angeles and London put together. And it's under 20 feet of gravel. Wow. And so there was a massive waves that covered the continents for a while there. And it could have been where we bounced the moon off the Earth on the northern hemisphere and tilted Earth in relation to the sun and also put it into a circular orbit around the sun. Apparently the year was around 360 days in ancient times before they did this. And now it's 365.25 days. As it's further out away from the sun, it takes a little longer to go around the sun. Also, after I wrote the book, I kept doing moon searches because I was kind of doing more research that was already published. But I was looking for cave paintings of the moon, ancient ones, to see if there was a moon prior to 11,000 years ago or 12,000. There isn't any moon that we could find. Right. And so I came across this little book written by Emanuel Velikovsky. Yeah. It's titled The First Three Words in the Bible. Anybody can go online and look it up. And it's translations from ancient Greek. Now, Emanuel Velikovsky, he'd written several #1 best-selling books. And Earth in Upheaval is one of them, and Worlds in Collision.
Yeah.
And they're #1 New York book reviews there in New York Times. So anyway, they didn't like his books. The scientists didn't anyway, the mainstream, but they could have been quite accurate. Well, anyway, he was translating these ancient Greek writings and other writings because he could read 6 languages, including Sumerian, ancient Sumerian, and other. And the guy was a Russian genius, you know. And he wrote this book, and it talked about, ancient Greeks talked about a time when there was no moon in the sky, and there were people on Earth, and they lived in the mountains, and they ate acorns. So anyway, there's many of those ancient books haven't even been translated, but he also talked about in chapter 3 of other tribes around the world, there was no record of any moon in the sky at the ancient times. And then you'd think that, you know, if there was a moon up there, that they painted on cave walls or something, you know.
Right. Yeah. That's very interesting.
We found the oldest thing that we could find was a Chinese stylistic drawing that kind of looked like a moon, but it was hard to tell because it was, you know, very stylistic. But it was only 9,000 years old that we could tell. And so what we did is I use an online computer. It's called Arizona EDU/Impact Effects. And we put the mass of the moon in this computer. Anybody can go online. Use the thing. It's based on rock hitting rock, but I don't think that was the case because the moon could have had ice on it. And it hit up there in the Arctic Ocean and tilted Earth 23.5 degrees within 15, 20 minutes, which would have caused massive flooding from 5-mile-high waves all over the planet. But anyway, we put the mass of the moon in the computer there. It's 7.35 E, 20 kilograms. And that's 7. With 20 zeros. And the mass of the Earth is 5.89 E, 24 kilograms. You can look it up. Just type in mass of the Earth into Google, and you can get that stuff right instantly. And 5.89 E, 24 kilograms. And we use an angle of 11 degrees, which is space shuttle entry angle, and figured it might bounce off the ice that way and get back into orbit. And we're just hypothesizing, rather try to figure out how it was done. Reverse engineering the whole project. And whoever done this really knew what they were doing. They probably did it to several other planets, terraform them. The way I figured it anyway.
Certainly seems that way.
And we use a speed of 2 kilometers per second, which is barely get it back into orbit. So anyway, it's an engineering project. The moon may have even be inhabited today. From what the YouTube says, there's more than 3 million people living on the moon. We don't know. I don't know anyway. But that's what you can get offline. There's a lot of strange things out there.
Yes, there certainly is.
Anyway, there are a lot of structures, ancient structures all over the moon. There's crashed ships there. There's all kinds of stuff. There's buildings. There's a tower that's many stories high, but they think it's made of glass. Maybe it's an old apartment building,
They say that the Mars also has the tilt of the axis is 23.5. Right?
Yeah, isn't that weird, huh?
Well, it seems to me like there's a correlation for sure. Yeah, an alignment of some kind with portals or something. Yeah, for sure.
Well, it's an ideal angle because you need the thermal convection for summers and winters to stir the atmosphere around more, and also the tides. And having a moon around there big enough to stir the tides is very important because it doubles fish populations, you see, because of saw the ice caps back 2,000 miles or more. And the data that came back from our little calculation there with this Arizona EDU/impact effect calculator, it would depress Earth's crust 5 kilometers and bounce back up to 1.3 kilometers. Well, the Arctic Ocean just happens to be 1.3 kilometers deep, the average depth.
Mm-hmm.
So go figure that one out. But
right.
Anyway, it definitely, I think it was an engineering project, and Mars had probably inhabited at one time. There's all kinds of weird stuff on Mars, and people are writing and discovering more things all the time. And whether or not it was killed off by a war or some natural impact of some kind, we don't know yet. But once we go there, Elon Musk might figure it out. So,
his car might get there first, right? Go ahead.
He put his electric car in orbit around Mars, so maybe he'll land it there later and drive around on the surface with it.
That'll be fun. Oh my goodness.
That's pretty
Go
crazy,
ahead.
huh?
Yeah. Well, I like the car. I'd like to have one of those. Very nice.
It's out there in space. All you got to do is go get it, right?
Yeah.
Floating around between Mars and Jupiter.
Very interesting stuff.
I don't know exactly where it is, but why did he put it out there? Why did he send a car out there? I mean, just for advertisement?
Well, people question if the car was actually a green screen too. Anything is possible at this point in the illusion, right? But yeah, it's very, very interesting.
Yeah,
they say there's a high radiation content. Radiation levels are very, very high on Mars. Supposedly there was some kind of a nuclear explosion of some kind. They're theoretically saying that it could have been some kind of a war, but who knows, right?
Yeah, even the moon itself, the astronauts are complaining about the heat in their suits, from what I heard originally. You see, the sun strikes the surface of the moon and it makes X-rays, and it's the X-rays that kill you, and it's about 8 to 10 X-rays, chest X-rays an hour that you're receiving there while you're standing on the moon. There's really no way to avoid it unless you lived in a glass tower or something above the surface. Then you might be able to not absorb so many X-rays. It's the reflectioner that kills you. It's not actual. There's hard particles that come from the sun pass through your body, and they do some cellular damage, but it's not as bad as the X-rays. Mm-hmm. So you can put a sheet of aluminum under your butt out there in space, and that's worse than anything else. It's not a radiation shield because the rays hit it, hard particles, and it turns into X-rays. So it just it's a problem. You're better off out there naked than you are with any kind of radiation shielding around you. But maybe water would slow it down. I don't know. The ancient Sumerian spaceships that Zacharias Sitchin talked about, is he said they were filled with water, and they came here in a voyage that lasted 8 years. And water being it absorbs impacts really well. I mean, it just slows bullets down and everything real quick. It's an incompressible liquid. It's just one of the very most essential things for life is, hydrogen, oxygen, and water.
Right.
So, also in the cold space, if you took a small meteorite through the hole, the water would come out through the hole and freeze instantly and plug the hole. So, because space is 256 degrees below zero, you get pretty close to absolute zero.
It's a good point you make right there. I mean, insofar as the hydrogen, oxygen, yeah, makes a lot of sense.
So, I understand Donald Trump's going to build a space force. And,
oh yeah,
I'm ready to go. I'm volunteering.
Well, me too. I'm trying. I think I'm too old, but I want to get off this rock. I've got to get out of here. I'll volunteer for Mars. I keep telling everybody.
Well, just give you something to fly around. It'd be more fun. Get off the planet for a while.
Oh yeah, I would love to do that. Go ahead.
So they say the Allen belt is bad. You cannot go through that and survive. I don't know how the guys made it to the moon, and it was a solar maximum too when John Glenn was walking on the moon. So they had more radiation there than normal. The first landers on the moon there. Armstrong, not John Glenn. Ellen and Armstrong.
It's late. Where's my coffee?
So anyway, getting late in the night here.
It's late over here too, but I appreciate you joining us this late hour anyway. We're going to hit a break in a few minutes here, but keep going. I'm sure it'll let me know.
Well, I used to live in Florida when I was in high school down there, and I met the Van Allen kids. There were two twin boys. They went to Titusville junior high there. I was in high school there, Titusville, Florida. They kicked us off of Cape Canaveral because Kennedy decided to put men on the moon. Eventually, we had to all leave the island there, but we drive the school bus every morning from where we lived. I was 14 miles north of Cape Canaveral. I could see the rockets with binoculars on their launch pads. I got to watch the first ones blow up over there. The Americans couldn't build a rocket that would fly. The Redstones and those just went off with tremendous explosion, just rattled the windows in the house, and big fireball and flames. Mm-hmm. And but the Germans got their Atlas and some of their rockets flying, and that's what won the space race, sort of, with the Russians. They're trying to compete with the Russians at the time. Get something in orbit up there.
Yeah.
Just all propaganda was unbelievable at the time, But the Van Allen kids, they were kind of weird little guys with big heads, the twins, twin boys.
And Henry, we're going to head for a break here. Everybody, you're listening to Ravenstar's Witching Hour. I'm your host, Solaris BlueRaven. My wonderful guest tonight is Captain Henry Kroll. We'll be right back. Stay tuned.